Welcome to Opus 4.8, Precision and Scale. This presentation covers one of the most significant capability shifts in Claude's history, orchestrating autonomous engineering through effort controls and dynamic workflows. At its core, Opus 4.8 gives you a dial. You decide how hard the model thinks. Let's walk through what that means in practice. For years, AI inference worked one way. You send a prompt, the model runs, you get an answer. Same compute every time. Black box. Opus 4.8 ends that model. It introduces tunable compute, a fundamental shift in user agency. You now actively manage the trade-offs between reasoning latency, token consumption, and output intelligence. Claude is no longer just an output generator. It is a computational engine you control. The effort control system maps directly onto a quality curve. At the lower end, rapid responses with minimal rate limit impact. Ideal for quick iteration and basic chat. At high, the default, you get equivalent token spend to Opus 4.7 but with superior performance. This is your everyday workhorse setting. At extra, also called X-high, the model enters deep reasoning spaces. It thinks more frequently and more deeply, pushing past initial shallow assumptions. At max, you get extended internal reasoning prior to generation. Fiduciary-grade responses for your highest-stakes tasks. A key insight: higher effort forces the model to challenge its own first answers before responding. Here is the full effort control matrix. Lower effort, shallow thinking, fastest speed, minimal token burn. Use this for rapid iteration and basic chat. High, the default, balanced thinking, optimized speed, token spend matching Opus 4.7. Use this for standard coding and general tasks. Extra or X-high, deep thinking, slower. High, token burn. Built for difficult tasks and long-running async workflows. Max, maximum thinking depth, slowest. Highest, token burn. Reserved for highest stakes quality and complex reasoning. One operational note: all 4 levels are available on every plan. Claude AI, Kerouac, and Claude Code. And rate limits in Claude Code have been explicitly increased to accommodate higher effort token usage. 3 headline metrics define Opus 4.8 operational baseline. First, cursor bench. Opus 4.8 exceeds all prior Opus models across every effort level. Tool calling is meaningfully more efficient. Fewer steps for the same intelligence. This is attributed directly to Michael Truel. Second, a 4 times reduction in silent code flaws. Opus 4.8 is 4 times less likely than 4.7 to allow flaws in its generated code to pass unremarked. It proactively flags input and output issues that other models miss entirely. Third, a 10% plus breakthrough on the legal agent benchmark. The first model to break that threshold on the all-pass standard. This demonstrates the reliability required for substantive, trusted, real-world handoffs. Dynamic workflows represent the second major architectural shift. Previously, every AI task was constrained by context windows. You could only ask Claude to hold so much in mind at once. Dynamic workflows break that constraint completely. A single session can now plan a massive task, deploy hundreds of parallel subagents, and run entirely unattended, from kickoff to final merge. The concrete capability: complete codebase migrations across hundreds of thousands of lines of code. Start the job, walk away, come back to a merged, verified result. Available now in Claude Code on Enterprise, Team, and Max plans. The dynamic workflow engine operates in 3 stages. Planning: Claude analyzes the overarching problem and structures a comprehensive execution plan. Parallel execution: hundreds of subagents run simultaneously within a single session, powered by Opus 4.8, sustaining significantly longer unattended runtimes than any previous model. Verification: Claude rigorously checks all subagent outputs against the project's existing test suite before reporting completed work. The test suite is the quality bar, not Claude's own judgment alone. This is not an assistant helping you code. This is an autonomous engineering system. The third capability: mid-flight steering via the Messages API. This is a developer-facing feature that changes how you control long-running agents. Previously, if you needed to update Claude's instructions mid-task, you had to interrupt the session, break the prompt cache, and restart. Now, developers can inject system entries directly inside the messages array while the agent is actively running. Dynamic updating: change instructions mid-task without stopping the agent. Cache preservation: updates happen without breaking the prompt cache or requiring a routed user term. Agentic control: seamlessly update permissions, adjust token budgets, or shift environment context while an asynchronous agent is running. This makes long, complex agentic workflows dramatically more controllable in production. Effort controls and dynamic workflows are designed to be used together. That combination defines a 2x2 capability matrix. Standard Copilot, default effort, single task. Baseline 4.8 efficiency for everyday work. Scaled data processing, default effort, dynamic workflow. Parallel extraction and translation at scale. Deep reasoning chat. High effort, single task, complex algorithmic problem solving in conversation. And in the top right corner, highlighted in gold, autonomous engineering. High effort paired with dynamic workflows. This is the target quadrant. Token limits are no longer penalties here. They are direct investment in fiduciary grade, multi-step engineering workloads that run completely unattended. Two industry voices validate this capability profile. Scott Wu, CEO, on Devon's experience, Claude Opus 4.8 uses tools cleanly and follows instructions with the consistency autonomous engineering workloads need to keep running unattended. This translates directly into faster capability gains for engineers building on Devon. Miguel Gonzalez, tech lead, the strongest computer use and browser agent model tested, scoring 84% on Online Mind 2 Web. It stays reflective and on task in the way agent workloads need to be reliable end-to-end. The signal is consistent. Reliability under autonomous, unattended conditions is where Opus 4.8 earns its position. Deployment and pricing. The Opus 4.8 model is available everywhere today. Effort controls are available on all plans, Claude AI, Cowork, and Claude Code. Dynamic workflows are available in Claude Code on Enterprise, Teen, and Max plans. Pricing. Base pricing is unchanged from Opus 4.7. $5 per million input tokens, $25 per million output tokens. Fast mode runs at 2.5 times speed and is now 3 times cheaper. $10 per million input, $50 per million output. Project Glasswing and Mythos cyber safeguards remain in development. Precision and scale available now. This is Claude Opus 4.8.